Hi, I'm Don Dawson. In this program, we're going to look at how you can prevent an arc flash and blast from being your last. Electricity. It's so common in our homes and workplaces that it's easy to take it for granted and to forget about its hazards.
But with more than 1,000 people being killed every year in electrical accidents and about 30,000 being injured, electrical safety literally is a matter of life and death. Electricity poses two major hazards to those who work with or around it. The most intense is arc flash, a sudden, violent release of electrical energy. Its powerful heat and blast effects can cause severe injuries and fatalities. The second is shock. When electric current passes through your body, it can cause burns, internal injuries, cardiac arrest, even death. Many people confuse the two and think that arc flash is just a type of shock, but it's not. So let's first look at what the difference is.
You know, it really doesn't take much electricity at all to cause a shock.
For example, 0.06 amps of electricity is just enough to make the filament in a holiday light bulb glow. But 0.06 amps passing through your heart is all it takes to put your lights out permanently. We all encounter situations that can result in a shock. Fortunately, there are safe practices we can follow to reduce our risk of being shocked in the workplace. It starts by keeping your eye out for hazards such as cracked wires and defective equipment. Inspect tools and extension cords before plugging them in. If you see torn insulation or exposed wiring, don't use them. This type of damage often results from unsafe work practices, like picking up electric tools by their power cord or unplugging an extension by yanking on the cord instead of pulling the plug. So it's important to treat tools and cords with respect. Another problem can occur when someone removes the ground prong from a 3-prong plug, so they can put it in a 2-prong outlet. If you find a plug that has been altered this way, don't use it. Inform your supervisor immediately so it can be repaired or replaced. Water conducts electricity and promotes shock, so whenever possible, avoid using power tools and equipment in wet conditions. And don't touch any electrical equipment that's wet. Make sure your hands are dry when you're working with electricity as well. Around an electrical source, a metal ladder behaves just like a lightning rod. So to avoid a shock, use non-conductive fiberglass or wooden ladders instead. As you can see, the potential for shock is all around us. But while it can obviously be hazardous, shock seems tame compared to arc flash.
Arc flashes are more common than you might think. Chances are you've witnessed them many times without knowing it.
When you see a flash of lightning, you're seeing an arc flash. It gives off intense light and loud noise. As lightning comes closer, you get a better idea of its violence and destructive power. And if it gets too close, you might not survive it. While lightning occurs naturally, man-made arc flashes generally occur in high-energy electrical systems that provide power for business and industry. Arc flash events send a couple of thousand workers to burn units every year. They cause disabling injuries and they kill. To better understand this hazard, let's take a closer look at what an arc flash is and how man-made arc flashes happen. Most of the time, energy moves safely through electrical systems, unless something happens to divert the power. When diverted electricity jumps through the air from contact to contact, or from a contact to ground, that's an arc flash. This can occur spontaneously when corrosion or conductive dust builds up in equipment. But most arc flashes result from mistakes that are made when someone is working on or near an electrical system. Touching a probe to the wrong circuit, or dropping a metal tool into the system, even digging a backhoe into an underground cable can all cause arc flash. Like lightning, these types of arc flashes happen very, very fast, releasing huge amounts of light and heat energy. Temperatures can reach 35,000 degrees Fahrenheit, 3.5 times hotter than the surface of the sun. So an arc flash will instantly superheat the air and can vaporize nearby structures and equipment. Another phenomenon that is often associated with an arc flash is arc blast. Basically, the equipment that is the source of the arc flash explodes. This can throw melted metal and debris outward at nearly the speed of sound. Workers lucky enough to survive a close encounter with an arc blast say it was like standing in front of a shotgun when it's fired.
Arc flash trauma is not a pleasant subject. You might wonder why we're talking about it at all.
But by examining the physical hazards of arc flash, we can gain a better understanding of what we can and cannot do to protect ourselves from it, and what type of PPE should be used in arc flash situations. The light released by an arc flash is literally blinding. Its heat can cause first, second, and third degree burns. It can make everyday clothing burst into flame and cause some synthetic fibers to actually melt into your skin. And when your clothes burn or melt, your body gets burned too, which means you could die from your injuries. This is why electrical workers always put on arc-rated protective clothing when they approach a potential arc flash source. The arc rating describes how much heat the clothing can resist without damage. To calculate the arc rating you need for a particular task, you determine how many units of heat you would receive where you are working if an arc flash occurred in that equipment. You then can choose clothing with an arc rating that meets or exceeds the protection level for that amount of heat. Other arc-rated PPE, such as gloves, safety glasses, or face shields, is selected in the same way. But the heat energy generated by an arc flash is not the only hazard. There is also the arc blast to consider. It can throw you across the room, causing additional injuries such as a concussion and broken bones. It can rupture your eardrums and collapse your lungs. It can throw equipment fragments just like shrapnel from a grenade. The unpleasant truth is that even arc-rated clothing and PPE cannot provide much protection from the violence of an arc blast. Remember, protective clothing and PPE are always your last line of defense. They may provide as much protection as possible when an accident happens. But as we will see, real safety comes from preventing the arc flash in the first place.
The best way to reduce the risk of arc flash is to create an electrically safe working condition before any electrical work begins.
This starts with powering down or de-energizing the equipment to be worked on. But there is more to it than that for good reason. Preventing electrical accidents also requires stringent adherence to safe work practices in every step of the work that is being done. For example, the equipment to be disconnected may be located at some distance from, even out of sight of, its power control system. Once the energy has been turned off, it is all too easy for someone who can't see people working on the equipment to turn the electricity back on unexpectedly. That's why the power control system must be locked out and tagged after being turned off. This physically prevents the equipment from being re-energized. But the equipment must still be treated as if it's energized and a potential arc flash hazard until it has been tested to make sure the power really is off. This means that the electrical workers who are servicing the equipment must continue to adhere to safe work practices and wear protective clothing and PPE even when they conduct the test. Another important step in creating an electrically safe working condition is establishing an arc flash boundary. To determine where this boundary should be, you calculate at what distance from the equipment the incident energy of an arc flash would equal 1.2 calories of heat per square centimeter. 1.2 calories per square centimeter is the heat value that will cause a second-degree burn on unprotected skin. This second-degree burn distance is where the arc flash boundary will be set up. The boundary must be clearly labeled and must physically restrict access to the area. Unqualified electrical service personnel and other workers may not cross the arc flash boundary. Even qualified electrical workers can't cross the boundary unless they are wearing appropriate protective clothing and PPE with the right arc rating. Once these precautions have been taken, the equipment can be tested. Only when it is verified that the power is off does an electrically safe working condition exist. That's when actual maintenance or repair of the equipment can begin, without any risk of arc flash or electric shock.
While preventing arc flash in your facility largely depends on the safe work practices of the qualified electrical workers who are servicing the equipment, there are things that other employees can do to keep safe around potential arc flash situations as well.
First, if you're not qualified and authorized to operate or work on electrical equipment, you shouldn't try. Small mistakes with high voltage can have big consequences. That's why it's also a good habit to stay clear of electrical equipment and potential arc flash sources under any circumstances. Warning labels make arc flash sources easy to recognize so you can keep your distance. Also, if electrical work is being done in your facility, you should keep in mind that turning off the power may not always be an option. You should always assume that the work is being performed on live, energized circuits and use all the caution that this type of situation demands. If an electrical worker has set up an arc flash boundary to protect you from arc flash, don't cross it.
We've seen that arc flash and electrical shock can pose a serious danger to people in the workplace. But there are ways all of us can contribute to reducing the risk. Let's review.
Always use caution around electrical power. Safe work practices will help to reduce your risk of injury from shock and arc flash events. To avoid being shocked, inspect power tools and other electrical equipment for damage before you use them. Take them out of service if you find problems. Avoid using electrical equipment in wet conditions if at all possible. An arc flash is a violent release of electrical energy that can cause severe damage and injury through a combination of heat and blast effects. PPE must be worn to lessen the physical risks of an arc flash. The most effective way to protect against an arc blast is to prevent it from occurring in the first place. The best way to keep an arc flash from happening is to create an electrically safe working condition by turning off the power. Unless you're trained and authorized to do electrical work, stay away from power systems, especially when they're undergoing maintenance or repair.
You can't take electrical safety for granted. But now that you understand the risks and how to avoid them, you have the power to get through every workday safely.